Hello everyone, welcome to my channel The Logic of Everything. Today we'll be solving a very complex problem which is based on the resolution of vectors in their equilibrium state. So if you do not know how to resolve vectors, I recommend you seeing the video I have made on the resolution of vectors. I'll leave the link in the description box. So today we have to evaluate tension for two masses in equilibrium state. So the question is, this is the figure for which this is T1, T2, T3, T4. This is A, B, C, D and E. Given is the mass of B is 10 kgs and the mass of D is 35 kgs. Cos 37 sin 37 cos 30 degrees is already given. The values have to be used in solving the sum. Question is, this figure is in equilibrium state, so you have to evaluate tension in all the four strings. That is, you have to find the values of T1, T2, T3 and T4. So the first thing we are going to do to solve this sum is to draw the free body diagram of D. I'll draw the X and Y axis. This is D. Now the weight will be 350 Newton, considering the value of G to be 10 meters per second square. I hope you can see the X and Y axis. And then this will be T4 and this will be T3. The angles are 53 degrees and 45 degrees. So when evaluating the resolution of vectors in an equilibrium state, you have to know that the x and y components of the vector will always be equal to 0. So right now I have to evaluate these, resolve these three vectors in such a way that fx and fy will be equal to 0. So to get the x component equal to 0, my equation will be T4 sine 45 minus T3 cos 53 is equal to 0. Now, how did I come to this equation? The answer is easy. I just resolved the T4 vector in the positive x-axis direction and the T3 vector in the negative x-axis direction. As the directions of both of these vectors, resolved vectors, is opposite, there is this negative sign which you can see right here. So if you do not know how to resolve vectors, please see that first. That will be very helpful in finding the resolved vectors of T4 and T3. So I get this equation. Now if I do the same thing for the y component, the y-axis component, which is equal to 0, will be T4 cos 45 plus T3 cos 37 minus 350 Newton is equal to 0. Now how did I come to this? The positive y-axis vector of T3 tension is equal to T3 cos 37 and the positive of this T4 is T4 cos 45. These are in the positive y-axis direction, and 350 Newton, the weight of the object B, is in the negative y-axis direction, which is why there is this subtraction sign here. I can write this as T4 cos 45 plus T3 cos 37 is equal to 350 Newton. Now this is my first equation and this is my second equation. I hope you have observed there are only two variables, T3 and T4, in both of these equations. T4 here, T3 here. So we can easily solve these sums. 1 minus 2, this equation minus this equation will give you 0.7 T4 minus T3 times 0.6. 0.6 is equal to 0. Another easier way of solving these two equations is, I hope you know that T4 sine 45 will be equal to T4 cos 45, because sine theta is equal to cos of 90 minus theta, and hence sine 45 is also equal to cos 45, and therefore T4 sine 45 and T4 cos 45 are equal. So subtracting 1 minus 2 will give me minus T3 cos 53 minus T3 cos 37 is equal to 350 Newton. Now we already know the value of cos 37 and the value of cos 53, which is simply sine 37. So I think we can easily equate the value of T3 in this equation, and the value of T3 will be equal to 250 Newton. So we already got the one of the tension in this figure. Now we just have to substitute the value of T3 in any one of these equations, and we'll get the value of T4 also. The value of T4 will be equal to, I think it's 212 Newton. Yes. So I solved this using simultaneous equations, x and y. T3, T4 were the only two variables I didn't know about. So I got the values of T3 and T4. Now come the part of T1 and T2. Now I'll draw the FBD of D. I earlier drew the FBD of D. Now I'm going to draw for B. This will be T2. This will be 100 Newton because the weight is always 10 into 10 acceleration due to gravity. This will be 250 Newton, and this is T3. Oh, sorry, I didn't know you couldn't see that. Sorry. This is T2, this is 100 Newton, this is 250 Newton, this is T3. The theta here will be 37 degrees, this will be 30 degrees, and this is T1. So again, this system is in equilibrium, and hence Fx will be equal to 0 and Fy will also be equal to 0. So what will be my two equations now? So please pause the video if you do want to search it. The one of the components, the x component, will be T2 cos 30 minus 250 cos 37 minus 100 Newton, which equals 0. This one. And another equation will be T2 sine actually. T2 sine 30 minus T3 sine 37 minus T1 is equal to 0. This is the x component and this will be the y component. So these are the two equations I will get after resolving t2, t3 and t1 in the x axis and in the y axis. So after solving these two simultaneous equations, I will get the values of T1 equal to 323 Newton and T2 equal to 346 Newton. I hope you understand this sum. This is the basic sum for understanding the vectors in equilibrium state. There is another method of solving this sum which can be done by Lami's theorem, but I would not explain that method in this video. So if you do have any doubts, please write them in the comment section. And thank you. If you do like the video, please like, share and subscribe. Thank you.